So let's use derivatives to determine where this function f of x equals x minus 1 over x squared plus 8, determine where that function is increasing and where it's decreasing. So first of all, note that this function is defined everywhere because there are no division by zero problems. X squared is always a positive number, and if we add a to that, we're going to get another positive number. There's no way that we're going to get 0 in the denominator. So what we want to do is we want to calculate f prime of x, which we'll do using the quotient rule for derivatives. That's going to be x squared plus 8 times the derivative, that's the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 2x, and that's over x squared plus 8 squared. And if we simplify this a little bit, we're going to get x squared plus 8 minus 2x squared, and then I have minus negative 1, so it's going to be 1 times 2x, so that's going to be plus 2x, and then that's of course over x squared plus 8 squared. Simplifying this a bit more, we get negative x squared plus 2x plus 8 over x squared plus 8 squared. And finally, it's going to make it a little easier to factor if I take out the leading minus sign and make this x squared minus 2x minus 8 over x squared plus 8 squared. Okay, so the question is, when is this expression going to be positive and when is it going to be negative? The way we do this is we make a sign chart. And I know that you all learned how to do this in pre-calc or algebra, so I'll just review how to do that. What you want to do is factor everything here. So this is going to be equal to negative x minus 4 x plus 2 over x squared plus 8 squared. So what we can see is that since whether an expression, whether a product in a quotient is going to be positive or negative depends on how many of its factors are positive and how many are negative. What we can see here is that we always have this minus sign. We're always going to have a negative 1, and then we have x minus 4 and x plus 2. So what you do is you write on a number line. You're going to write where the zeros are, which are going to be at x equals 4 and x equals negative 2, and then we're going to write in all the factors that can affect whether it's positive or negative. I'm going to leave the denominator out in this case just because it's clearly always positive. It's a positive number squared, which is always going to be positive, so that's not going to affect anything. It doesn't change anything. What we do have here is we have a constant of negative 1, that's the minus sign. We have x minus 4, and we also have x plus 2. So what we can see is that the negative 1 is going to be negative. I'm just going to write a negative, negative, and negative. It's going to be negative on this interval from negative infinity to negative 2. It's going to be negative in between negative 2 and negative 4, and it's also negative there for greater than 4. So for x minus 4, this is going to be negative here, and then as long as x is greater than 4, the expression x minus 4 will be positive, and the expression x plus 2 will be negative if x is less than negative 2, but if it's greater than negative 2, it will be positive. So it'll be positive there and there. What we can see is that because we're going to have here the product of three negatives, this is going to be negative. Here we've got the product of two negatives and a positive, which is going to be positive, and here we have the product of a negative and a positive, which is going to be negative. So what we can see is that the function f of x is, in other words, recall what this means. What we're doing, let me just back up for a minute. This was not values of the function. This was values of f prime. In other words, what we found is that the derivative f prime of x, I'll just write that up there, is negative, positive, and negative on these intervals. What we can see is that f prime is less than 0 for negative infinity to negative 2. F prime is greater than 0 for negative 2 to 4, and f prime is less than 0 for the interval 4 to infinity. So we can conclude that it's because it's less than 0 in this first interval, we can conclude that it's decreasing on that interval, that it's increasing on this interval here because f prime is positive, and we can conclude that it is decreasing on the interval for infinity because f prime is negative there. So that's the answer.